All right, ladies and gentlemen, here is the review for your circles, parabolas, and ellipses test, which is Monday. Make sure you are aware of all of the stuff that we did on that 9.1 webassign. I went through that day in class. I did a video of the frequently asked questions because you'll see stuff on there like given a circle and the diameter is something, figure out the equation of the circle so you know how to do that with the diameter. Remember, you can have notes. I'd like it to be just a page or so because if you guys have too much more than that, you're going to get yourselves confused, which I don't want you to do. The equations will not be provided on the test itself, so just have your notes available for you guys to use. All right, so the first question says, find the standard form of an equation of a circle. Guys, equation of a circle. X minus h quantity squared plus y minus k quantity squared equals radius squared. Remember, the center of your circle is your h and your k, right? So if we're given a center and we're given a point on the circle, so what they've given us is the center point and then something on the circle, right? Fill in what they gave you. This is your h, this is your k, this is an x value, and this is a y value. So plug that in to first find the radius. So you would say 5 minus 3 squared plus 5 minus negative 2 squared equals r squared. 5 minus 3 is 2 squared plus 5 minus negative 2, same as plus, so 7 squared equals r squared. 4 plus 49 equals r squared. 49 and 4 is 53. So r equals the square root of 53. It's not plus or minus, it's just 53 because we're talking about a length. 53 does not break down, so we can just leave it as a square root of 53. And then if you're going to write the equation of your circle, now the equation of our circle would be x minus, the h part is 3 squared, plus y minus negative 2 would be y plus 2 squared, equals the square root of 53 squared, which would just be 53. And there's the equation of your circle for number 1. All right, number 2, I'm going to scoot over a little bit. Number 2, again, they give you center and a point on the circle. So use the equation of a circle to figure out what the radius is first. So this is my h, my k, my x, and my y. So I'm going to say 4 minus 2 squared plus 5 minus negative 5 squared equals our radius squared. So now as we simplify, 4 minus 2, 2 squared, plus 5 minus a negative gives me plus, so 10 squared equals radius squared. 4 plus 100 equals radius squared. 104, equals our radius squared. So your radius is the square root of 104. Now, if they're asking you just specifically to find the center or to find the radius, if you find the radius to be something that can be broken down, guys, you need to make sure that you know how to break that down. 104 is the same as 4 times 26. So this radius here would be 2 root 26. But since they're not asking for just the radius, you don't have to break it down because in your equation, when you write it, you're going to write the radius squared. So when we write the equation of this circle, given a specific h and k, I have x minus 2 squared plus y plus 5 squared equals our radius squared. So the square root of 104 squared is just 104. And there is your equation of the circle. All right, 3 and 4 is asking for x and y intercepts. Guys, we've done this a million times. To find x and y intercepts, you plug in 0. If I plug in 0 for x, I'm finding the y. If I plug in 0 for y, I'm finding the x. I'm going to plug in 0 here for x plus 7 squared plus y minus 3 squared equals 5. 7 squared plus y minus 3 quantity squared equals 5. 7 squared is 49. Subtract 49 from both sides. So I get y minus 3 quantity squared, that's a 2, equals negative 44. When I take the square root of both sides, guys, all right, first of all, when you put the house on, this becomes plus and minus, yes. So I have y minus 3. But if you notice here, I have a negative sign underneath the radical. That means this would be an imaginary solution, not real. So it doesn't actually cross the intercept here. So you can stop right there and just say there's no y-intercept. All right, now we're going to find the x-intercept. I'm going to plug in 0 for y. So I have x plus 7 squared plus y minus 3 squared equals 5. Don't just assume because one of the intercepts was none that the other one is none. It might end up being that way, but it may not. So make sure you work this out, guys. We have x plus 7 quantity squared plus 0 minus 3 quantity squared equals 5. So I still have my x plus 7 squared plus, this gives me negative 3 squared equals 5. Negative 3 squared is 9. Subtract 9 from both sides. I get x plus 7 quantity squared equals negative 4, okay? Take the square root. Again, plus or minus goes in front. But you have x plus 7 equals the square root of negative 4. If you notice, ladies and gents, there's an I there, so it's imaginary. That means this does not cross the intercept here either. So your answer would be no x-intercept. Don't just assume, though. Sometimes circles can cross one axis and not the other. So make sure you do all of the work algebraically to figure that part out. Okay, same thing goes for intercepts here. We're going to do the exact same thing. Just change color here. All right, I'm going to plug a 0 in for x. 0 in for x. That means we're going to find the y-intercept. Y plus 4 quantity squared equals 39. So negative 1 quantity squared plus y plus 4 quantity squared equals 39. This is 1. Subtract 1 from both sides. You get y plus 4 squared equals 38. In order to get the square root, I'm going to get the square root to go away, so I have y plus 4 equals plus or minus root 38. Now in this case, guys, as soon as you get here, you have to see if your square root breaks down. If it does, break it down. If it doesn't, that's fine. You can just leave it. So I'm going to subtract 4 from both sides, and I get y equals negative 4 plus or minus the square root of 38. We want your answer written as an ordered pair. So you would say 0, comma, negative 4 minus the square root of 38. And the other intercept would be 0, comma, negative 4 plus the square root of 38. Have to have it written as an ordered pair. We specify that on the test, I promise. So now we're going to go do our other intercept. We just found, excuse me, the y-intercept. Now we're going to find x. So we have x minus 1 squared plus 0 plus 4 squared equals 39. X minus 1 squared plus 4 squared equals 39. 4 squared is 16. I'm going to subtract 16 from both sides, and I get x minus 1 squared equals 23. Now we want to get x all by itself. We don't want x squared, so I'm going to take the square root. Remember, when you put the square root on, you have your plus or minus. X minus 1 equals plus or minus the square root of 23. Again, if that broke down, I would do it. It doesn't, so we're just going to add 1 to both sides. So you get x equals 1 plus or minus the square root of 23. And again, we're going to write our intercepts as ordered pairs. So 1 minus the square root of 23, comma 0, and 1 plus the square root of 23, comma 0. And there's our intercepts. All right, coming down to the next one, guys. Obviously, our equation of our circle is not written in standard form. I know this is an equation of a circle because it says it right here. We have to find our equation written in standard form, then identify the center and the radius. So the first thing I'm going to do is I'm going to group my x's together and my y's. So here's my x's, here's my y's. All right, we're going to move this 9 to the other side because we're going to have to complete the square. So we have x squared minus 16x plus my box plus y squared plus 4y plus your box equals negative 9. When we're completing the square, we take our b term, so it's negative 16, and divide it by 2. That gives me negative 8. So in my parentheses, my binomial is x minus 8 squared. And then to figure out what goes in the box here, you square that answer, so I get 64. Since we're adding 64 to the left, I'm going to add 64 over here on the right. Now I'm going to do the same thing. I'm going to take my b term of my y's, divide that by 2, and I get 2. So my parenthesis, my binomial, is going to be y plus 2 quantity squared. To find out what goes in the box, I square it, and I put that right there, so it's going to be plus 4. What you do to one side of the equation, you do to the other, so this equals, over here, we're going to add 4. Negative 9 plus 64 plus 4 gives me 59. So now I can say, oh, I can see exactly what my equation in standard form is. It's right here. And then from that, I can extract my center, which is my h and my k. This is my h, this is my k. So my center would be at positive 8, negative 2. And my radius squared is right here. So my radius would be the square root of 59. Okay, guys, over here we're going to do the exact same thing. I'm going to get my x's together and then my y's. You see they're not in the same order, but no big deal. So I have x squared plus 12x plus the box plus y squared minus 8y plus the box equals, and we're going to move this 9 to the other side, so it becomes negative 9. Take my b term, 12 divided by 2 gives me 6. So I know my binomial is going to be x plus 6 quantity squared. And then when I square this value, I get 36. So when you add 36 to one side, you have to add to the other side. Same thing with our y's. I'm going to take my negative 8 divided by 2, and I get negative 4. So my binomial is going to be x minus 4 quantity squared. And then I'm going to square this, and I get 16 over here that I added to the left side, so I'm going to add 16 to the right side. So we are left with x plus 6 quantity squared plus y minus 4, this should be y, I don't know why I put x, squared equals 43. So there's your equation of your circle in standard form. You know that your center is going to be your h and your k. So it's at negative 6, positive 4, and my radius is right here as r squared, so it's the square root of 43. And again, if 43 could have been broken down, you absolutely would have to do that. Make sure you guys do that on your test. All right, now we come to standard form of a parabola, okay? We're going to tell you on the test, guys, make sure that you have your standard form of a parabola or a ellipse or a circle, whatever. You should have those formulas written down somewhere so you can just easily access them right in front of you. So I went ahead, just took a screenshot so you guys can have this right in front of you so you can see here is our standard form of an equation for a parabola. Depending on if it's vertical or horizontal, x squareds, remember, if you have an x squared, it's going to open up if it's positive, down if it's negative. All right, this is positive, this is a negative. If it's y squared, your parabola is going to open to the right if it's positive, to the left if it's negative. Remember too, guys, parabolas open towards the focus and away from the directrix, away from the directrix. So just make sure you have that written down somewhere so you don't forget. Okay, a good thing to do, ladies and gents, is to draw yourself a little picture here. Okay, so I'm just going to draw a quick little picture. I'm going to put my vertex at negative 5. Say this is negative 5 and say this is 6 up here, okay? And they tell me that my directrix is at x equals negative 2. So I have a directrix here. Remember, your parabola is going to open away from the directrix. So it's going to open in this direction. It opens away from your directrix. So is this a positive or a negative? It's negative. And is it a y or an x? It's y. So this is a negative y squared parabola. All right, that's a good thing to just put in your memory so you guys can see, okay, where do I need to look? So I need the equation that starts with y squared. So I have y minus k squared equals 4p times x minus h. Well, they've already given me my x and my h, right? Here's my h and my k. Sorry, I have my h and my k. It's my x and y values of my center. So I'm going to say, all right, so my formula is y minus k squared equals 4px minus, okay, perfect. So I say y minus 6 quantity squared equals 4p times x minus negative 5 squared. Well, two things here we need to look at. First thing we need to look at is 2 negatives gives me a positive, but I need to know what this p value is. The way that you figure out what p is the distance from your directrix to your vertex, or from your vertex to your directrix. So if I counted how far my vertex was from my directrix, right? It's how many spaces? It's 3 spaces, because this is at negative 5, and my directrix is at negative 2. So that my equation would be y minus 6 squared equals 4 times 3, my p is 3, so it's 12 times x plus 5 quantity squared. Your p value is the distance from the vertex to the focus, or the vertex to the directrix, so then you multiply that by 4. So same thing here, I'm going to draw a picture. My vertex is at 5, 1, 2, 3, 4, 5, negative 6, 1, 2, 3, 4, 5, 6, so it's like right here. And they tell me that my directrix is at y equals positive 2, so it's up here at positive 2. Your vertex and your directrix are the same distance away as the directrix and the focus. We'll talk about that in a second. But if I have a directrix at y equals 2, that means my parabola is opening away from it. It's opening downwards. So this is a negative x squared parabola. All right, so that tells me which formula to look at. This is my h and this is my k. Now I'm going to figure out how far away the directrix is from my actual center. Well, if my vertex is here and the directrix is up here, how many spaces away is that? Well, negative 6 to positive 2 would be negative 8. Your p is going to be negative 8. And the reason it's negative is because your parabola is opening downwards. So you have your formula of x minus h quantity squared plus, not plus, I don't know why I said that, equals 4p times y minus k quantity squared. So I have x minus 5 squared equals 4 times negative 8, that's my p value, times y minus a negative 6 squared. And just clean that up. You have x minus 5 quantity squared equals negative 32 times y plus 6 quantity squared. Remember, your directrix and your focus are equidistant from the vertex. Your parabola opens away from the directrix and towards the focus. So make sure you guys are on top of that. All right, here, if they're asking us to find the standard form, the vertex, the focus, and the directrix and all that, we can do that. We are not written in standard form, so the first thing we need to do is write it in standard form. Similar to completing the square with the circle, but it's a tad bit different. We're going to keep our y's on this side. I have y squared minus 6y plus the box. I don't know what it is. And I'm going to move this stuff over here. So that would be negative 4x and a positive 3. So now as I complete the square, I bring down my b term. So it's negative 6 divided by 2 gives me negative 3. So I know that my binomial is going to be y minus 3 squared. And then when I square this value, it becomes positive 9. What you do to one side, you add to the other. So I have 9 over here. So I have y minus 3 quantity squared equals. Well, on the right-hand side, I have negative 4x. 3 plus 9 is 12, so plus 12. I want my x value to be 1x. I want that term in front of x to be 1. So I look here and I say, oh, well, I can factor out a negative 4. So if I take that negative 4 out, I'm left with x minus 3. So now I have my equation in standard form. This is a y minus 3. This is a y equals. So I look up here and I say, okay, y equals, that means y is with the k and x is with the h. So my center here is going to be at positive 3, positive 3. Now we have to figure out where the directrix is and where the focus is. So remember, guys, this value right here is 4p. P is the distance between the directrix and the vertex, or the focus and the vertex. So you would say negative 4 equals 4p. We're going to divide both sides by 4. So my p-value is -1. So now let's draw a picture. It's y squared parabola. That means it's going to open left or right. Okay, that's how we're looking at it. If my p is negative, that means it's going to open to the left. So if my center is at 3, 3, 1, 2, 3, 1, 2, 3. Here's my center, correct? And we're opening, it's a left-hand side, I guess we could say. My focus is going to be 1 unit away, 1 unit to the left of this parabola. So my focus point would be at 2, 3. And my directrix would be the opposite direction. So my directrix would be at 4, 3. Because remember, we open towards the focus and away from the directrix. And number 10, we're going to do the exact same thing again. And I'm going to group my x's. So I have x squared plus 6x. Then I have my box because I'm going to complete the square. And I move this to the other side. So I have equals positive 4y plus 7. Take your b term. 6 divided by 2 equals 3. So I know that my binomial is x plus 3 quantity squared equals, when I square this, I'm at 9 here. Then what you do to one side, I added 9. I'm going to do to the other. So I have 4y plus 16 over here. 4y plus 16. Well, I want y to have a coefficient of 1. So I'm going to say x plus 3 quantity squared is okay over here. I'm going to factor out a 4. So that leaves me with y plus 4. Now this is an x squared parabola. Here we're in standard form. X squared means it's going to be positive. Moves up. My center is going to be, guys, at -3, -4. So -3, -4 is going to be here-ish. And I need to figure out what the distance is from the directrix to my vertex and then the focus of the vertex. So I'm going to take this value. So 4p equals 4. Divide both sides by 4. And my p value is 1. So my vertex is right here at -3, 4. So my directrix is going to be 1 above it, and I'm sorry, it's a positive parabola, right? We open upwards. So my focus is 1 above, my directrix is 1 below. All right, ladies and gents, now we're talking about ellipses. This is what we did yesterday, right? When we talk about ellipses, it's important for you to have the standard form of an ellipse equation. So if you don't have those written down in front of you, I'll give you a little hint right here. Well, let's figure out something about our ellipse first. My foci are at 2, 1, so 2, positive 1, and then at 10, 1, so 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1. So if you notice, my ellipse is going to open this way. This is a horizontal ellipse. So you should look on your notes and say, okay, I need the horizontal standard form equation of an ellipse, and it looks just like this. We have x minus h squared over a squared plus y minus k squared over b squared. Remember, A is our major axis, B is the minor. So the bigger denominator goes with the way that the ellipse is shaped. Since it's horizontal, A, my major value, would be underneath my x value. So you guys should have that in front of you. Our center, how do you find the center of an ellipse? You're going to take the 2 foci and find the midpoint. So I'm going to take 2 plus 10 and divide by 2, and then 1 plus 1 divided by 2. So my center is at 6, 1. Okay, I'm going to write that over here. I'm going to say center, because that's important, is at 6, 1. That's my h, and that's my k. Okay, they told me here that the minor axis length is 16. Remember, A is your major value, B is your minor. So when they give you the minor axis length, that is equivalent to 2 times B. So I'm going to say 2B equals 16. Divide both sides by 2. So B equals 8. So over here, we're going to find A, B, and C. So if I know that B is 8, I'm going to put that right there. So I know that my C value, if you look at your little cheat sheet that I gave you, your C value is the distance between the center, which is at 6, 1, so 1, 2, 3, 4, 5, and the foci. So it's left, right. You literally, guys, all you have to do is count. My center value, the X value, is at 6, and the foci are at 2 and 10. So how far away is 6 from 2 and or 10? In each direction, it's 4 units. If I add 4, I get 10. If I say 6 minus 4, I get 2. So my value of C, the distance between the center and either foci, is 4. Now you have to find the A value. Well, we have a little equation that helps us do that. C squared equals A squared minus B squared. So if C is 4, I have 4 squared equals A squared minus B squared is 8. So 16 equals A squared minus 64. We're going to add 64 to both sides, and I get A squared equals 80. When I take the square root of that, 80 is the same as 16 times 5, so I can break that up into 4 root 3. So A equals 4, I'm sorry, square root of 5, not 3. So A is 4 square root of 5. So if I needed to write the standard form of my ellipse, all right, I can do that because I have all the stuff I need now. I have my H term, I have my K term, I have my A term, and I have my B term. So I'm going to write it right here because I kind of ran out of room. No, actually I'm going to write it over here so you guys can see it. So I'm going to say I have X minus 6 squared over A squared, which is square root of 80, which is 80, plus Y minus 1, quantity squared, that's part of our center, that's the Y part of our center, over B squared, which is 8, so it's 64 equals 1. Okay, guys, moving on here to number 12. I'm not sure why this is being like this, but that's okay. I'll just erase this part here. Okay, so we are looking here, and they're talking about a standard form of an ellipse, so we need to remember that we're looking at an ellipse, and we need to, first thing we should do is graph it. All right, so I have my foci is at 2, 1, so 2, 1 is one of them, and then at 6, 1, 2, 3, 4, 5, 6. So again, this is going to be a horizontal. We know it's horizontal because our foci are spread apart, wide, left to right, not up and down. So I know the standard form of my ellipse equation that I'm going to be using is X minus H squared over A squared plus Y. Why is this not? So Y, try this one more time. Y I'll use my finger. Y minus K, quantity squared over B squared. So we need to find all the stuff that goes with this, all right? So the first thing we're going to do is find the center. And the way that we find the center is it's the midpoint. Remember, we'll say midpoint of the foci. So I have 2 plus 6 divided by 2, comma, 1 plus 1 divided by 2. So my center, 2 plus 6 is 8. 8 divided by 2 is 4. 1 plus 1 is 2, divided by 2 is 1. So my center is going to be at 4, comma, 1, right? 4 is my H, 1 is my K. Now I'm looking, and they give me that the minor axis length is 16. So remember, 2A is our major axis length. 2 times B is our minor. So we now have to find A, B, and C, guys. So we have enough information to start finding some of our letters. I need to find A, I need to find B, and I need to find C. If my minor axis length is 16, then I know that I can say 2B equals 16. Divide both sides by 2, and I get B is equal to 8. So my B is 8. My C value, remember C is the distance between the center and the foci. So if my center is at 4, 1, That's my center, and my foci are at 2, 1, and 6, 1. You just count. So my C value would be 2. They're 2 spaces away from each other. So in order to find A, we'll say C squared equals A squared minus B squared. We have that formula. So 2 squared equals A squared minus 8 squared. 4 equals A squared minus 64. We're going to add 64 to both sides. And I get A squared equals 68. So my A value is going to be the square root of 68. Guys, 68 can be broken down into 17 times 4. So that would be 2 root 17. So my A value is 2 root 17. So now that we have all that information, we can figure out our formula for the equation of our ellipse. It's x minus h. The h part of my vertex is 4, so quantity squared, plus y minus 1. That's the k part of my vertex, quantity squared. X is going to be over our a value squared, so a value squared would be 68 over our b value squared. B is 8, so it would be 64, and it's always set equal to 1. All right, now we come to a completing the square. Now it's for an ellipse. So guys, remember the same concept goes for all of these problems that we've been doing. We want to keep our y's together and our x's together. So I'm going to bring my x's together, and I'm going to say x squared plus 6x plus whatever the box is that I'm going to add. And then over here, I'm going to group my y's. So I have plus 4y squared minus 8y plus the box equals, and then we're going to take this 3 and we're going to move it to the other side. So we have positive 3. So when we complete the square, we're going to start right here. I'm going to take my b term, 6 divided by 2 equals 3. So I know my binomial is x plus 3 quantity squared, and when I square 3, that becomes 9 right here. If I add 9 to one side, then I'm going to add 9 to the other side. Now we're going to do the same thing with the y's, but the only thing is I want that y coefficient to be 1. So I look and I say, oh wait, I can factor out a 4. So when I factor out that 4, that leaves me with y minus 2y. What is going on here? Y minus 2y plus the box, which is going to send something to the other side in just 1 second. So guys, we're going to take our b term. Our b term is negative 2. So negative 2 divided by 2 is negative 1. So I know that this binomial is going to be x minus 1 squared. And then when I square negative 1, that becomes positive 1, so plus 1. Now, I have to account for that 4 that we took out. So I have to say 4 times 1 is 4. And then that's what we're going to add to the other side. So right here, I'm going to have a plus 4. So I'm left with here x plus 3 quantity squared plus x minus 1 quantity squared equals, when you add up 3 plus 9 is 12 plus 4 is 16. So if you guys remember, when you have the equation of an ellipse, it always has to be set equal to 1. So in order for this to be set equal to 1, I would have to divide everything by 16. So I have x plus 3 quantity squared over 16. I had my 4 out in front here. So 4 divided by 4, 4 goes into 4 once, 4 goes into 16 4 times. So this would be plus x, y minus 1. Why is that an x? This should be y. Y minus 1 quantity squared over 4 equals 1. So you can determine a lot of things from this problem. We just found the standard form of the equation, but you guys could tell me the center, right? By looking at this, the center is going to be at negative 3 comma 1 because x is first, y is second. I know that this is going to be a horizontal ellipse because my major axis is A and it's with my x value. So you guys should be able to recognize that from this problem. All right, same thing for the second one. This next one should say number 13. I'm going to keep my x's together and my y's together. So first thing I'm going to do is say, okay, I got my x is 9x squared plus 36x plus the box. And I have plus, now I'm going to put my y's together. Y squared minus 10y plus the box. And I'm going to move 52 to the other side, gives me negative 52. So remember, guys, when we complete the square, we want to have our a term to be 1. So I look here and I say, oh, I can factor out a 9. So this becomes x squared plus 4x plus the box, right? We have to remember that that 9's out there. We have to account for it. So I'm going to say my b term is 4 times 2 equals 2. So my binomial is 9 times x plus 2 quantity squared. And then when I square this, this becomes plus 4. So remember, we're not just adding 4 to both sides, we're adding 9 times 4, which would be 36. I'm going to add 36 right here to this side. Try and add 36. Okay, now I'm going to do the same thing with my y's. I have a plus sign here. I'm going to complete the square, so I bring down this negative 10. Negative 10 divided by 2 gives me negative 5. So my binomial is going to be y minus 5 quantity squared. And then when I square negative 5, I get 25. So I'm adding 25 here. I'm going to add 25 to this side. So when I add negative 52 plus 36 plus 25, I get positive 9. And again, my equation of an ellipse needs to be set equal to 1. So what am I going to do to get 1 on this side of the equal sign? I'm going to divide everything by 9. So divide this by 9, divide this by 9. 9 divided by 9 gives me x plus 2 quantity squared over 1 plus y minus 5 quantity squared over 9 equals 9 divided by 9 is 1. So again, from this, guys, you should be able to tell me that the center is at negative 2, positive 5, and we know that this is my h and this is my k, because h is with the x and k is with the y. And I know that this is going to be what kind of a ellipse? It's going to be a vertical one, because the bigger number, the bigger denominator, is with my y value. So my a here is 9. All right, guys, in this last two equations, they're both ellipses, all right? You're given the ellipse of an equation in standard form, so you're asked to find the following. When you don't have anything being added or subtracted to your x squareds and your y squares, and you know that your center is going to be at 0, 0. This is my h and this is my k, all right? When you're asked to find the vertices and the foci, all right? It's a good thing to do to find A, B, and C. You need to do that so you can figure out how far the foci is from the center and all that good stuff. So A, in this case, would be 25 squared, right? I'm sorry, A squared is 25, so that means your A value is 5. Your B value is the smaller number. It's 16. B squared is 16, so your B is 4. And then to find the C value, you would say C squared equals A squared minus B squared. So it's 5 squared minus 4 squared, 25 minus 16. So C squared equals 9. So your C value is 3. And the reason that is important is because they're asking you here to find the foci and the vertices. So let's remind ourselves how to find those things. This is really important that you guys remember this. The focus, or the foci, is the way that you find that. You're going to add and subtract the C value. The C value, I have a dead spot on my iPad, to the X part, or the H, of your center. And the reason that we're adding it to the X part of the center is because this is an X ellipse. It's a horizontal ellipse because you're leading with x squared and A is your major axis. So in order to find the foci, I'm going to say, okay, I need to take the Y part of my... So if you were going to graph this, right, your center here is at 0, 0. Well, to find the foci, to find your focuses, however you want to say it, it's going to be 3 to the right and 3 to the left. So that's where we get that our foci would be at 0, -3, and 0, +3. So we'll take our center, which is at 0, 0, right? Here's my center. And I'm going to find my x vertices, I'm going to add the a value, and I'm going to subtract the a value. So my vertice for my ellipse would be at 0, +5, and at 0, -5. Those would be my vertices for the x-axis. For the y-axis, I'm going to take my center of 0, 0, and I'm going to add and subtract the b value. So my vertices would be at 0, 4, and at 0, -4. Okay, last one, here we go. If we're going to identify the center, first of all, this is my h and this is my k, because h is the x value, k is the y value. So my center would be at -3, +5. So again, guys, to find your vertices and to find your foci, right, you need to have your a, b, and your c. So my a value and my b value, right, the bigger denominator is your a value. So a squared would be 25, so my a value here is 5. Right, this is the bigger number, so this is your a squared. My minor would be b squared, so square root of 16 would be 4. And to find c, I would use my formula, c squared equals a squared minus b squared, which would give you 3. So this is going to be the distance. Your c value is the distance from the center to the foci. So if you look at this, guys, -3, 1, 2, 3, 5, 1, 2, 3, 4, 5, right? Got a point here. So my foci, my focuses, are going to be to the up and down. Why is it up and down? How did I know to go up and down? Well, since the bigger number here, the denominator is with y, that means it's a vertical ellipse. That's really important to remember. So in the last problem, we added 3 to the x values. Well, now we're going to add 3 to the y values. So I'm going to add and subtract 3 to my y value here. So my foci would be at -3, 5 + 3, and at -3, 5 minus 3. So that's where I get the point -3, 8, and then the point -3, 2. Same concept as before. You're going to find all 4 vertices. You're going to have 2 on the x-axis, 2 on the y. So I take my center, which is at -3, 5, right? This is my x value, my h. This is my y value, which is my k, all right? In this case, my x-axis is my minor. Oops. And my y-axis is my major. So this is where I'm going to use the a value for y, and I'm use the b value for my x's. So again, I have my center of -3, 5. All right, so this is my x value, this is my y value. I'm going to use my b is 4, and I'm going to use a is 5 here. So I'm going to subtract and add to get my vertices. So I'm going to be at -3, 5 + 5, and -3, 5 minus 5 here, which would give me -3, 10 for my vertice, and -3, 0. And then over here, for my x values, I'm going to do the exact same thing, but I'm going to use my minor values. So I have -3 + 4, +4, 5. And then I have -3 minus 4, 5. So that gives my vertices for this would be -7, 5. And +1, 5. So there's my vertice here and here.